We're going to begin transitioning from the plotting points approach to being able to set up an equation for a line in something called the slope-intercept form, which you may already be acquainted with, but it's a much faster way to graph lines and has some more useful information. So if we're going to do that, the first thing we have to know is if it's called the slope-intercept form, we're going to need the slope. So what we're going to do here is discuss in this section the slope of a line. Now we're going to get to the mathematical definition in just a few slides, but the first idea is that it's the rise over the run. So another fancy way of writing it is, how are we changing when we go up and down? Because those are the y values, and this is a fancy sign. This is change. As we get to higher math and all the way to calculus, you're going to see this means change. So how are the y's changing as we go up and down? That's the rise. How are the x's changing? And x's are the right and the left, so they're calling that the run. Okay? So we have different possible slopes here. So if you have a line going here, we always go left to right. We're going up the numbered line, up the x line. So as we go left to right, would your line be going uphill? If you were driving along it, are you going up? If so, you have a positive slope. And vice versa, since we go left to right, if you had a line and you were driving downhill as you went left to right, you would have a negative slope. Alright, so if we're asked to find the slope and we have the picture, what we're going to need is 2 points. This is a little hard to tell. We'd want 2 places where it hits on the grid exactly so that we can read it. I think, oh no, here's what they're saying. They're saying this one here and this here. So if I want to be able to tell how I've moved, the points are hard to do. If I want to tell how I move between the 2 spots, I want it to be exactly on a corner of one of these grids, so right where they intersect. So I've selected 2 points that the grid matches up nicely, and I'm going to do the rise over the run. Now, hold on, let me see what they've given us here. Yeah, not that helpful, so let me just do it. So the rise is first, it's on the top. If I start at this one right here, do you see that I would go up 1, 2, 3, 4 in order to be in the same vicinity here as the other dots? So my rise, I went up 4 to get on that same line. So I've gone up 4, and now to get over to it, I would go 1, 2, 3, 4, 5. Now, I started at this dot one more time. I went up 4. So up is positive. I went in the positive direction 4, so it's a positive 4, 2, 3, 4. I went to the right, which is where the positive x's are. So I'm going in the positive direction on the x. So a positive 4, positive 5. That's my slope, which is symbolized with this m. So let's find 2 intersection points. I've got that one. So you see how I'm hitting right at the corner of the grid. And I'm going to go there as well. That hits right at an intersection point. Now my slope is going to be, so if I start here, I go up 2, and it's positive because I'm going up toward the positive y. So I'm going up 2, and the up and down are on the top. And I'm going 1, 2, 3, 4, 5 in the positive x direction. I'm going toward the positive x's, so my slope would be 2 over 5. Okay, try this one if you want to. I'm going to find 2 clear intersection points. Now, if I want to journey from this one to this one along the grid lines, so here's my slope. If I'm going along the grids, I would go up 3, 1, 2, 3, and it's in the positive y direction. I'd go over 1, 2, 3, 4, and that's in the positive x direction, so that would be my slope. Okay, so now what we're going to do is we're going to have somewhere we're going to be going downhill, so we're going to get some negative slopes. So I've found, yeah, here appears to be 2 spots where I intersect. You could choose any 2 and it'll still work out. I'm just checking to see if I'm exactly where I would have intersected. Yeah. Now, I'm going to start at this top one. And I'm going to go, so my y direction, do you see I would be now going down 2 steps? So it's not positive 2 anymore. I went down in the negative y direction 2 steps. Now the x is still a positive, 1, 2, 3. So what's changed is that this is a negative slope. And what happened was I had to go down 2 steps in the y and then 3 over in the x. So I got negative 2 over 3 this time. So I'm going to mark 2 points that are on the corner, a good intersection. I guess they mean this one. So I think they mean this point there. Okay, so I'm starting here, and we're going to move to the other line. 1, 2, 3, 4. So I've gone down 4 in the y because I'm going away from the positive x's. And now I'm going over 1, 2, 3 in the x, and that's still positive for the x. So I'd get negative 4 over 3. Now suppose you had chosen the other way. Suppose that you had started at this one and worked the other way. Let's see what will happen. So I'm going to go start at this one, go to the other dot. I'd go up 1, 2, 3, 4. Now if I'm here to get to the dot, I'd go back 1, 2, 3. So look what happened. It doesn't matter if the negative is on the top. We saw this with fractions earlier. Either one of the, I can move it there, I can move him out front. It doesn't change anything. So we get the same answer. So you could either go down and over or up and back, but you're going to get the same result. Okay, I'm marking some intersection points. That's the hard part. Can you find where they're saying you're trying to hit? I think that's what they mean. Now you'd get the same thing going either direction, but I'm going to start here, go down 1, 2, 3. And I'm going to go right 1, 2, 3, 4, 5. And it should be a negative slope because I'm going downhill. Okay, more of the same. Can we find? Now there's a point where they intersect. And here's another one. Okay. I'm going to go from this one over, but you could go either way. So if I start here, 1, 2, 3 up. So 1, 2, 3 up, and that's positive. Now 1, 2, 3, 4, 5 over, and that was also positive. So positive up, positive to the right, m is 3 over 5. Okay, I think that and that. Okay. Let's go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and over 1, 2, 3, 4. And both of those were positive. Up and to the right are both positive. Okay, I was having trouble finding 2 intersection points. So that looks like it hits the grid. So I'm going up 1, 2, 3. Going to the right 2. And that was positive because I was up, and it was positive because I was going to the right. Okay, now we're going to get to the formula for finding slope, and instead of just looking at the graph in just a second. So what I'm about to say, at this point it sounds like you just need to memorize it, but I'm going to show you why this is true in just a minute. Well, let's see, hold on. Maybe it's time to just show you now. Yeah, I'm going to jump ahead. Let's look at this formula here. And so we have a formula for a slope, and I'm going to go back and do it on the screen I was on. You can find, we really did this visually. What we did was we started at one y point and we went to the other. We started at one x point and we went to the other. So basically this is saying what's the difference between the y values and what's the difference in the x's. That's exactly what we did. So y2 minus y1, x2 minus x1 is the mathematical expression for finding the slope, the mathematical equation. Now, yeah, I'm going to do all this in a different order. We'll come back to these because this will make more sense when you see how to just do slopes. So let's do this. I've got 2 points. I want to put them into the equation. So here's my equation. So it doesn't matter which one you make the first point and which the second. Just make sure that you match them up. So here's x1 with y1. Here's x2 with y2. Don't mix that. So don't like x1 and y2. Don't do that. So let's put in the second y value. I put in a 5. Let's put in the first y value. I put in the 2. Now on the bottom, I'm putting in the second x value, which was a 4, the first x value, which is a 1. Now we were doing this when we did it visually. It's the same thing, but mathematically we're doing this. 5 minus 2 is 3. 4 minus 1 is 3. So my slope is 3 over 3, but that reduces, and we get a slope of 1. So I'm going to make this x2, y2, and I'm going to make him x1, x1, y1. Okay? Now my formula was y2 minus y1 over x2 minus x1. So let's plug those in. So 3 minus 5, 3 minus 5 over 6 minus 8. 6 minus 8. Okay, so just tidy this up. I get negative 2 over negative 2, which could be simplified. It's a slope of 1. So I could divide those, it becomes 1. So x2, 2, y2, x1, y1. That's supposed to be an x. Okay. So you'll get this formula down really quickly if you don't already know it. So my y2, so y's are on top. 9 minus 5, 9 minus 5, 5 minus 1. So they keep doing the same thing. So I get 4 over 4, which again is 1. Okay, now I'm assuming we're going to get some here that are not the same thing. So I've plugged in, so here's my second y and here's my first y. Now they've plugged it in. Now notice this will happen quite a bit. The formula has a negative in it. So if I'm putting in a negative 3, do you see those double negatives would become a positive? So this is really 4 plus 3. Now on the bottom, x2 minus x1. Here's my x2, there's my x1. Just plug it in. Once again, I had the double negative, so that's a plus. So I have negative 7 plus 2. You owe me $7, but you got back 2. You get negative 5. Now we can put the minus in front, doesn't change anything. And there's my slope. Okay. Now I'm going to just go ahead, maybe not yet, maybe next time. Let me write that formula again. Those are supposed to be x's. Okay, so negative 1 minus 4. Negative 1 minus 4 over 2 minus negative 3. So we did have the double negative thing in a row again. So you owe me 1, you owe me 5 more, you owe me 5. Now on the bottom, do you see that this would be plus? So now it's 2 plus 3 gets me 5. Now if I reduce this, that's negative 1. So I'm going to show it like this. So we could cancel those 5s. If you do, they leave 1s behind. So this is really now like negative 1 over 1, or just negative 1. Or you could just think of this as division. Negative 5 divided by 5 is negative 1. Okay, now there were some, I actually thought they'd give us some harder ones, but let's go back now to the slope of these lines. So I actually, what am I doing? I forget without memorizing which is which here. So I always use this formula to tell me, here's what I'm saying. Let's look at this line. X equals 8. Doesn't that mean that no matter what the values of y, x is always 8? Remember, that's what we said when we looked at this. It makes a line, a vertical line, where x is always 8. Well, if we use the formula, doesn't it, no matter what 2 points I pick on this line, aren't they always going to be 8? Now look what happens. I've got something on the top, but the bottom is 0. Now, you're not allowed to divide by 0. The universe breaks, the laws of math are destroyed, and so that's something we call undefined. Under the line is undefined. 0 under the line is undefined. So you're not allowed to divide by 0. So that's why a vertical line has an undefined slope. And I do not have it memorized. I just go back to the formula and think it through like this. Now let's try the other one. So I've got -5 minus -5. Because it's a y line, I would go to -5, it would make horizontal. It's always -5. Remember that discussion? Now, I don't care what the x's are, it doesn't matter. But the y lines are all the y points are always the same. So I have -5, double negative, it'd be +5. So that's going to just be 0 over something else. So horizontal lines have a 0 slope, and this is why. So just by plugging it into the formula. Okay, so we have x equals -4. So I would have on the bottom, it's always -4. So this is going to wind up getting a 0 on the bottom. It's a vertical line. It has a slope that is undefined. The m is undefined. If we did it this way, it's always 7 no matter where you are on this line. The y's are always 7. So you're going to get 0 over x2 minus x1. So it's always going to be a slope of 0 for a horizontal line. Okay, I think we covered everything there. So I don't memorize those for vertical and horizontal lines. I just think about that formula. And don't get overwhelmed by the formula. The formula is exactly the same thing as you're moving up and over, exactly the same.